So adding and subtracting polynomials is combining like terms. Make sure that whatever sign is here in the middle is what you're using. If it's a minus, you're going to want to distribute it. But for addition, then you just add the two numbers. So I have 6x to the fourth, but I don't have an x to the fourth to combine with it. So 6x to the fourth. Here I have an x to the third, x cubed, but I don't have one on the left. So it becomes plus 8x to the third.
Oh yeah, that's four above that.
Then I have 2x squared here plus negative 5x squared. So what is 2 minus 5? Negative 3x squared. You need a pencil? I have a couple.
I got you.
Oh my
Don't
goodness.
even worry about it.
Then I have a minus 6 and a plus 12. What is negative 6 plus 12? Negative 6 plus 12.
6.
Plus 6. So that's the answer.
Yeah. I'm basically doing your notes for you.
So the next thing we're looking at is how this is written in function notation. If I am given this function, which is that first piece, and as f of x, and this function, which is the second piece, as g of x, what you will see written in the question is f plus g of x. This means exactly the same as that. So it's pretty straightforward when you're adding. When you're subtracting, you have to remember that all of these have to be subtracted. Based on lots of years of teaching this, most of the time you forget. So the recommended procedure is take the minus sign and distribute it first. So this plus 8x cubed becomes negative 8x cubed. This minus a minus, this becomes plus. This minus and that plus becomes minus. And then you change this to a plus in the middle. But the signs are with the numbers. So now it's 6x to the fourth. Again, we still don't have a 6x to the fourth. So that stays the same. I mean, we don't have an x to the fourth to combine it with. But now we have negative 8x to the third. Then we have plus 2x squared and plus 5x squared. So that is plus 7x squared. And then we have minus 6 plus minus 12, which is negative 18. Negative 6 plus negative 12 is negative 18. So the next one, we're given the two functions, and then we're told to find f minus g. So what are we doing here, adding or subtracting?
Subtracting.
Subtracting, because it says f minus g. Remember that the order matters here for subtraction. For addition, it doesn't. Addition is commutative. 2 plus 3 is the same thing as 3 plus 2. But 2 minus 3 is not the same thing as 3 minus 2. So you must do it in the correct order for subtraction. So 6x to the fourth plus 2x squared minus 6. And then we subtract. So this is the function notation for the one we just did. So we're subtracting this, so that becomes negative 8x cubed plus 5x squared minus 12, just like it did here. And this notation means exactly the same thing. So this is the same problem as that, but it's just the notation that's different. So addition is commutative. This means that order doesn't matter. I can hear you, so my microphone can too. The order does not matter for addition. That's what commutative means. 2 plus 3 is equal to 3 plus 2. Subtraction is not commutative. So now we have 2 examples to practice. The first one wants us to take f and subtract g. So we're going to have f, which is 7x minus 5, and we're going to subtract all of g, which is 3 minus 2x. I put it in parentheses so that you remember you have to distribute the negative sign. So we're going to distribute this negative sign, so that's going to be negative 3, that's going to be plus 2x, and we change that to a plus sign. So now I have 7x plus 2x, which is 9x, and I have negative 5 plus negative 3, which is negative 8.
Can you explain that again?
So because we're subtracting, the g function here is 3 minus 2x, so we're subtracting the whole function. So what I do is I distribute the minus sign, so this one becomes negative, that minus a minus becomes plus, and then I change the subtraction to addition. So now it is 7x plus a positive 2x, which is 9x, and it is negative 5 plus negative 3, which is negative 8. So this is f minus g of x. Notice that we've switched it. In the next problem, it is now g minus f. So we have g minus f, g minus f, g is 3 minus 2x, but I'm subtracting f, which is 7x minus 5. Yes?
I'm confused on why is it, did we take out the negative for the negative 2?
When we distributed the minus sign, the positive 3 became negative and the negative 2 became positive, because it's a minus times a minus. So we're going to do the same thing here. We're going to distribute this minus sign and get negative 7x. And we're going to distribute it here and get plus 5. So this is negative 7, becomes negative 7x plus 5. And then we add. So 3 plus 5 is 8. Negative 2x minus 7x is minus 9x. So this is g minus f. If you are more comfortable with it, or if it's easier for you, you can also do this vertically. So I could have 3x minus, no, not 3x, 3 minus 2x, just repeating this last one, 3 minus 2x, subtracting 7x, but we're going to have to line them up, minus 5, so we have to line them up vertically, one way or the other, if we're going to do it vertically. But now we need to distribute the minus sign first. So this becomes plus 5, and distributing it to here, it becomes minus 7x. And then you can do it vertically. 3 plus 5 is 8. Negative 2x plus, negative 2x minus 7x is minus 9x. We get the same answer, it's just vertical instead of horizontal. So I want you to come back and fill in your quick write later, but we need to move on to the other things. This paper on the back, this gives you some practice problems here. I want to do, these are lined up, set up so we can do it vertically if they're the same. So this one is easy enough. They want us to add f plus g. The x squareds line up, the x's line up, and the constants line up. So negative 6x squared plus 10x squared is 4x squared. 3x plus 4x is 7x. Minus 7 plus minus 2 is minus 9. But when you look at problem 2, this is x to the 7th, and this is x to the 6th. So you can't add these two together, right? So ideally, we would rewrite everything, 8x to the 7th. We don't have an x to the 6th, so 0x to the 6th, minus 6x to the 5th, plus 0x to the 4th, plus 4x to the 3rd, plus 0x squared, minus 6x plus 0. And obviously I should have left more room.
Do we need the square? Because there's no numbers that have a square.
If you notice that already and you want to skip it, that's fine. We talked about the fact that it's descending order, so that's why I just emphasized that descending order, even if some of them are missing, that's the order that has to be in. So for this one, you can write 0x to the 7th if you want to, but we don't have one. But we have a 15x to the 6th, which is going to be positive. We have a plus 4x to the 5th. We don't have a 0, we don't have an x to the 4th, so you could have skipped those two. We have a minus 3x cubed.
Oh, I remember.
We don't have an x squared, so you could have left it out. We don't have one in either part. We don't have an x, so plus 0x, and then plus 2 to add to our 0 that's over here at the end. So then it's vertical, so you just, now it's in order, you just combine like terms. So 8x to the 7th, because they told us here in our directions we're adding. And then that 0 plus the 15, so plus 15x to the 6th. Negative 6x to the 5th plus 4 gives us negative 2x to the 5th. 0 plus 0, I'm just going to leave that out of the answer. We don't have that. 4x cubed minus 3x cubed is plus x cubed. And 0 plus 0, we don't have that. Negative 6x plus 0x is negative 6x. And 0 plus 2 is plus 2. So that's your final answer, and if you want to rewrite it all together, you may. So at this time, I want you to do problem 3 and 6. We need a subtraction. We did a subtraction in there. And 8. Do problems 3, 6, and 8. So I'm going to pause my video while you do that.
I'm so confused about how we're supposed to put
The signs, when you distribute the minus sign here, that's the same thing as multiplying each thing in the parentheses by a -1. So if I have plus 8x squared and I multiply it by -1, I now have -8x squared, or cubed, sorry. So then I had plus 2x squared, I multiply by -1, I get -2x squared. And so on. The -5x times -1 is plus 5x. You're on the recording. And the -1 times the -1 is plus 1. So then at this point, you just combine like terms. So you look for exponents that match. If there's one that matches, you combine the two. If there isn't one that matches, you just use the one that exists. So here we have 4x cubed and minus 8x cubed, so we get -4x cubed. We have plus 6x squared and minus 2x squared, which gives us plus 4x squared. We have -9x plus 5x, which leaves us with -4x or minus 4x. And plus 1 and plus 1 is plus 2. So that is adding and subtracting. That's review from Algebra 1 where you combine like terms. The next page that we're going to look at is multiplying polynomials. I should have actually. So for multiplying polynomials, you have to multiply each term. So you're going to multiply each term in the first function or the first polynomial.
Miss, it's frozen.
Thank you. So you're going to multiply each term in the first polynomial by each term in the second polynomial. You can do this horizontally, but generally it's a nightmare because either you get lost or you get mixed up or you forget the signs. It's much easier to get the correct answer the first time. Why is it doing that? It's much easier to get the correct answer without mistakes quickly by using the vertical method. So by the second polynomial. That's a Y. It looks like a G. So the two polynomials I'm going to multiply, -x squared plus 2x plus 4. And we're going to multiply by x minus 3. If you're doing this horizontally, you have to remember to multiply the x by this term, and this term. Write that all out. Multiply the -3 times each of those three terms. Write that all out. And then look in all of that to find and combine your like terms. More often than not, students who do it that way get a sign error somewhere, and they miss the whole problem, even though they did a lot of work. If you do it this way, and I've already shown you this earlier this year, you multiply it in the same way that you did back when you did numbers. Like if you multiplied 1, 2, 3 times 4, 5, you know, back in elementary school, you would multiply the 5 times the 3 and get 15, 5 times the 2 and get 10, and add the 1, which is 11. 5 times 1 is 5, and you carried the 1, so that's 6. Then you did the same thing with the 4. 4 times 3 was 12. You put that 2 under the 4 and carry the 1. 4 times 2 is 8, and 1 is 9. And 4 times 1 is 4. And then you added up the digits. So that was 5, that was 3, that was 15, and that was 5. This is how you did it in elementary school. We're going to do the same thing, except we're using terms from polynomials.
What are the first numbers?
1, 2, 3, and 4, 5.
Miss, can I use the restroom and mine this time?
David
take
is
the
waiting,
time?
and then you may go after David.
Okay, I'll go after Delilah.
Okay. So we're going to follow that same procedure. -3 times 4 is -12. -3 times 2x is -6x. -3 times -x squared is plus x squared.
That was on before, just so you know.
Now we go to the next term. X times 4 is plus 4x. X times 2x is 2x squared. And x times -x squared is -x cubed. I left off my plus sign there. Now, as long as you've written it down in straight columns, you just combine like terms. -12 is here. -6 plus 4x is -2x. X squared plus 2x squared is 3x squared. And -x cubed plus nothing is -x cubed. This is your answer, and this is the way you are least likely to make mistakes. Anyone still copying that? So just like we had function notation, f plus g of x, we have function notation for multiplying. For function notation for multiplying, you have your two functions, so f of x and g of x. And f of x is this top one here, g of x is the second one. The function notation set either, it looks one of two ways. It will either say f of g of x like that, or it may say f times g of x. We try to stay away from this one because one of the next things you're going to learn is called composition of functions. And the composition of functions is f and a little open dot. This means composition. But when it gets printed on your tiny screens, you often can't tell the difference between, you often can't tell the difference between this little circle and that dot. So we try to avoid using the dot. We just put, if you see FG like this, it means multiply. If it's a test and you're in doubt, if you see a spot and you can't tell if it's a dot or a composition circle, then ask me, and I will clarify it for you. So multiplication is also commutative, so that means that f times g of x is equal to g times f of x. It is commutative. So this is a chart of things that you should memorize, or whatever you call it, to get it stuck in your head. This one I've already told you need to know. This one is called difference of squares. And my pre-cal students were using it today. You have to know this one. You will use it a lot this year, next year, and in calculus. Difference of squares. This one you definitely need to know. This one is the sum, the perfect square of a sum, and this is the perfect square of the difference. The only difference between these two is that's a plus 2ab and this is a minus 2ab. But when it's a perfect square, it'll be the first term squared at the beginning and the second term squared at the end, and the middle term is going to be a times b times 2. Whatever the first term is times the second term times 2. That pattern always exists. So if you see it in this format, you know how to factor it without going through the factoring steps, and that saves you time. Or if you see it in this side, you can expand it very quickly. These last two, sometimes you will have these on a formula chart. If I'm giving you, say, a unit test and they're not giving you a formula chart, I will remind you, and we'll go over the way to remember these again. We're going to have a whole lesson on using the binomial theorem to expand these. In a few days, a few more class periods, we're going to have a whole lesson on that. So this will become clear at that time. The other way you can remember this is what I told you before. I called it SOAP. It's equal to A plus B. So this is the same sign. If this one was plus, this is plus, so that's the same sign, times A squared, the opposite sign, so now it's minus the minus 2ab, and then the last one is always positive. This one is fully expanded. This one is in sort of a factored form, so the same sign, that's an S, the opposite sign, and the last one is always positive, so we call that SOAP. It's just a way to remember it. So the formula for the subtraction then will be A minus B, which is the same sign, and then A squared, opposite sign, plus 2AB, minus B squared. Erase the 2. It's just minus AB and plus AB. So erase the 2. I still had the 2 from up here stuck in my head. There's no 2. It's A squared plus or minus AB plus, it's always positive at the end, B squared. So same, opposite, always positive. This is same, opposite, and always positive. So that's just a way to remember the sum and difference of cubes formulas. Any questions about the formulas themselves? Anybody not finished? So we have the practice problems on the back. One through 3 are straight up multiply. Let's work question 4, just because of the notation. You know that g of x in parentheses with the exponent on the outside, you know that that means g of x times g of x, right? So the other notation for this would be g times g of x. So that means, oh, well, that's easy enough. G of x is just 4. So this becomes 4 times 4, which is 16. Oh, no, never mind. That was G from up here. We need G from over there. Sorry. We should use this G here. So this means, it does mean G times G. Shouldn't have erased that. So we have negative 5x minus 1 times negative 5x minus 1, G times G, and then we follow the pattern. Negative 1 times negative 1 is plus 1. Negative 1 times negative 5x is plus 5x. Then negative 5x times negative 1 is plus 5x. And negative 5x times negative 5x is plus 25x squared. So then we combine like terms. We get 25x squared plus 10x plus 1. The last part is applying this to an application. A rectangular pool has a level floor, so it doesn't go down and have a diving board. The length of the pool is 3x minus 1 feet, and the width of the pool is x plus 8 feet, and the depth of the pool is x plus 6 feet. Write an expression for the volume of the pool as a product of the binomials. So how do you get volume? Volume is what? Length times width times height, but in this case depth, right? So the volume related to x is the length, 3x minus 1, times the width, x plus 8, times the depth, x plus 6. Now remember that multiplication is commutative, so you can do these in any order. Personally, I would do these two first because FOIL makes it quick or easy, or you can use the vertical method or the box method or whichever method you like. So if I do these, if I do x plus 8, I'll go ahead and do it vertically, but probably in person I would do it as FOIL, just because it's easy and I don't have to write anything else down. So 6 times 8 is 48. 6 times x is 6x. X times 8 is 8x and x times x is x squared. Don't have quite enough room for that. So x squared here is x squared. 6x plus 8x is 14x plus 48. Now to get the volume, we have to multiply this times 3x minus 1. So x squared plus 14x plus 48 times 3x minus 1. Draw that better. So negative 1 times 48 is negative 48. Negative 1 times 14x is negative 14x. Negative 1 times x squared is negative x squared. Then 3x times 48. 3 times 8 is 24. Carry the 2. 3 times 1 is 3. 54. Negative 54x. No, positive. Positive 3x times positive 48. That is not enough. Oh. Yeah, I multiplied the wrong two things. The x is here. 3 times 8 is 24. Carry the 2. 3 times 4 is 12. Plus 2 is 144. Then 3x times 14. I need to make some more space. So x times x is x squared. 3 times 4 is 12. Carry the 1. 3 times 1 is 3, and that's 42. And again, I don't have enough room. And then 3x times x squared is 3x cubed. So 3x cubed, 42x squared minus x squared is plus 41x squared. 144x minus 14x is 130x. And minus 48 at the end. So this part says write an expression in standard form. So that's what we've done. 3x cubed plus 41x squared plus 130x minus 48. Any questions about multiplying polynomials? In your Delta Math assignment last class, there was one that you couldn't do because you know what even and odd degree is, but you don't know what an even or odd function is. So I had told you to hold off on those skills that required that. So you picked up a discovery sheet on the way in today, and I'm going to have you work that discovery sheet now so that you will know how to tell the difference between an even and an odd function. So, this one, it says even and odd from a graph. I wanted you to practice whether it's even degree or odd degree. That's part of the question, but this question, they didn't have one that didn't also include, is it an even or an odd function? So you picked up a paper on the way in that, I don't have it. Let's see. So this is a discovery activity. You need to finish it before the end of class. Get the passes back. I don't. Who has the pass? Who? Oh, and y'all are in line? So this is a discovery activity. Use a calculator, draw the graph, don't make it a sketch, make it accurate, plot some points and then draw it, and then answer these questions. To find f of negative x, you plug in negative x where the x is, noting that the parentheses go around it and then the exponent, and then you check, is it the same, is it the exact opposite, or neither, and you write that here. Then look at the exponents. Are they all even or all odd or a combination? We only had one exponent. It was even, so we wrote that here. Then you turn it over to the back, and you fill in those 3 blanks in the chart. So the symmetry you'll fill in after you draw the graph and do that. You can work together in your teams, but you should finish this before the end of class. Once you do this, you will draw a conclusion here at the end once you look at your chart, and once you draw that conclusion, you will know how to answer the questions in the Delta Math assignment. So at that point, you can go back to this Delta Math assignment and you can finish the last 2 skills. Right? And this Delta Math assignment is due, it's due tomorrow. I better change it since we only covered it today. So, B-Day. For my A-Day classes, it'll be due the 13th. My B-Day classes, it'll be due, I'll just make it due Monday for everybody. No, Tuesday. Monday's a holiday. And then it'll be late. It'll be late the next day.
Hi, whenever, let's